Here's an example data set from a survey I once did in a class I was teaching in fall 2011. The class was called Empirical and Mathematical Reasoning 16. And there were, say, two types of students who were visiting the class on the first day. Some were freshmen and some were not freshmen. And I conducted a survey, and one of the questions in the survey was, what is the probability that you will enroll in this class? Because they were just shopping the class at that point. So there were 5 freshmen and there were 13 students who were not freshmen, and if we look at what they said was the probability they take the class, I get the distributions shown here. On the left-hand column, right here, I've listed the probabilities for all the students in the whole data set. The smallest probability is 0.1 and the highest probabilities were 1. And then I've ranked them. So 0.1 was the lowest, right? And then the next 2 were tied, so I average the number 2 and 3. Here's the 4th value, etc. So I turn those into ranks. So if I make pictures based on the ranks, right, then here are the ranks of the freshmen's probabilities and the ranks of the non-freshmen's probabilities. If I do the rank sum test and I look at actually all the possible allocations, and here this is actually approximately all the possible allocations because there are so many. There are many, many thousands of possible ways to allocate 5 and 13 that I just have a subset here. If I do that, then I get this reference distribution. The red line shows the sum of the ranks in my group. So the left-sided p-value, the proportion of these rank sums that are to the left of the line is 0.195 via the rank sum test. But note this looks a lot like a normal distribution. And so if I just compared this to a normal distribution with the mean and variance that I would calculate given the formulas in the previous slides, I'd get a very similar p-value, 0.187 instead of 0.195. It's not exactly the same, but it's very similar. Now, the idea is that when you use the normal approximation, when you use the normal curve instead of the exact curve as the reference distribution for a rank sum test, you're going to get something really, really close to correct, and it's probably going to be a lot faster. So that's something that's very common. The substantive results will almost always be the same. In other words, the conclusion you draw from the p-value will almost always be the same. So what are we saying about the rank sum test? We don't have to make any distributional assumptions. That will have more meaning when we talk about tests that do have distributional assumptions. But we don't have to say anything or assume anything about what the data looks like initially. Outliers are no big deal with a rank sum test because as soon as we take the ranks, there will be no outliers. Censoring is not a problem. Even if we don't know exactly what a value is, we just know it's greater than some particular value. That's okay. Rank sum test doesn't have a problem with that. The randomization or permutation distribution depends only on the sample sizes. In other words, we don't even have to know the values. If we have 10 values and there's no ties, we know we just have the numbers from 1 to 10. So the reference distribution depends only on the sample sizes, and that's how we know it's going to look like a normal curve. When should you not use this normal approximation? When should you actually list out all the possible randomizations for the rank sum test? You should do it if there are a lot of ties, because if there are a lot of ties, it's not fair to say that those curves that were on the left will look uniform and the ones on the right will look normal. And if you have an extremely small sample size, I showed you with those pictures that with a sample size, a total sample size even of 10, it looked as if the curve on the right was pretty normal. But that wasn't as true for sample sizes of 4 or 6. So if you have an extremely small sample size, you may want to avoid that normal approximation. But most of the time for the rank sum test, you can essentially do it by hand. You can calculate the sum of the ranks in the smaller group. You can figure out what the mean and variance of the normal curve should be, and then all you have to do is check that against a normal curve.